Why is it that a transmission line's resistance is insignificant and its inductance is greater or more prominent than that of a distribution line? Because the distance between conductors is much greater in transmission systems than in distribution systems, the flux linkages between the conducting phases are greater, resulting in a much larger external component of the line inductance in these systems than in distribution lines. As a result of this, the transmission line has 3 or more times the resistance of the distribution line, rendering its contribution to the modular impedance value negligible as well. External inductance is small in distribution systems and its reactance value is comparable to the resistance, which results in a large inaccuracy when these systems are calculated without taking resistance into consideration. Any transmission line, conceptually, has 4 parameters per meter. It has an inductance L, a resistance R, a capacitance C, between its conductors, and a leakage conductance G, also between its conductors. These factors are determined by the transmission line structure, the cross-section and the material of its conductors, and the distances and insulators between its conductors. Electricity is transmitted via a transmission line, which operates at a significantly greater voltage than a distribution line's. As a result, the spacing between the wires is far greater than that of the distribution line, resulting in significantly more magnetic energy storage and, thus, a higher inductance per unit length. In terms of resistance, which is dependent on the cross-section and material type, it will be equivalent for the same carrying capacity, as the cross-section is chosen to minimize ohmic losses. As a result, the transmission line's LR ratio will be greater than that of the distribution line with the same current rating. Another way of saying this is that X is dominant in transmission lines in relation to resistance, while the opposite is true for distribution lines. #IAmAHobbyist